Hello everyone, welcome to this new video on refrigeration system. In this video, I will explain about two types of refrigeration system, namely vapor compression and vapor absorption. Refrigeration is an important aspect of both domestic and commercial food management. The creation of the first modern fridge in the late 1800s was the beginning of a great era in the food preservation. This has further been advanced by new technology which has seen a current production of more than 1 billion refrigerators around the world. The one main reason why refrigerators are used in business and at home is to keep food cold, and by which food stays fresh for longer, thus helping in cutting down the wastage in both home and business. Refrigeration is a method of reducing the temperature of a system below that of the surrounding and maintaining it at the lower temperature by continuously abstracting the heat from it. Refrigerator system works on the principle of Clausius statement of second law of thermodynamics. Clausius statement says that it is impossible to design a device which works on a cycle and produce no other effect other than heat transfer from a cold body to hot body. That is, heat transfer can only occur spontaneously in the direction of temperature decrease. But this natural phenomena of heat transfer from high temperature body to low temperature body can be reversed with the help of external work. External work is done by power absorbing devices like compressor or pumps by consuming electric energy. And the device used to reduce the temperature of a body by using this method is called as refrigerator. Refrigerator exchange the heat present in the substance placed inside it with the atmospheric air. Initially, when any substance or food kept inside the refrigerator, its temperature would be equal to atmospheric temperature. When the system starts to cool it down, the temperature difference between the system and the atmosphere increases due to transfer of heat from the substance to atmosphere. This process of cooling happens in a cycle and opposite to natural law of physics. A standard refrigerator will have mechanical elements that make it easy for it to achieve and maintain cold temperatures. That includes a compressor, condenser, expansion valve, and an evaporator. Additionally, the refrigerator has to use a refrigerant, which is a substance used to provide the cooling effect. The refrigerant has to pass all these components, and in each it is altered to achieve required temperature and pressure. Freon, ammonia, fluorochlorocarbon, hydrochlorocarbons, hydrofluorocarbons, etc. are the commonly used refrigerants. Refrigerants are selected based on many factors like its environmental acceptability, chemical stability, material compatibility, performance, and safety factors. Let's discuss about all different parts of the refrigerator, starting with the compressor. Compressor work is to control the flow of the refrigerant. Refrigerant entering the compressor will be in gaseous state, and when it is compressed, pressure and temperature increases with reducing the volume. This pressure helps refrigerant to flow in the flow circuit made by either copper or aluminum tubes. Reciprocating compressor is the most commonly used in home and commercial refrigerators. Pumps can also be used if the refrigerant is in liquid state. The condenser works by condensing the refrigerant or by converting it into liquid state. The refrigerant entering the condenser is hot and pressurized. Condenser cools this refrigerant by rejecting the heat to either atmosphere or to any other low temperature liquid flowing in another circuit. Small refrigerators such as the one used in a home use air-cooled condenser. They are ideal when the refrigerant quantity is small. The air-cooled condenser is also called coil condenser because it comes with aluminum or copper coils at the back of the fridge. Air-cooled condenser are further divided into natural and forced type. Natural convection condenser uses the natural flow of air to cool the refrigerant, whereas forced convection condenser uses a fan to draw in cold air. In large plants where there is more refrigerant, water-cooled condenser are used. They use water to provide the cooling effect on refrigerant. Water-cooled systems typically work better when operating in high ambient temperatures. The expansion valve helps in further reducing the pressure and temperature of the liquid refrigerant which comes out from the condenser. The sudden drop of pressure and temperature produces a cooling effect. The expansion valve also regulates the amount of refrigerant used in meeting the load requirements. The loads in this case are the products or substance that need cooling in the refrigerator. There are various types of expansion valves. They include capillary tube, automatic throttling valve, thermostatic expansion valve, and float valves. The evaporator is a cabin made by tubes through which liquid refrigerant flows and absorb heat from the food placed inside the refrigerator. It acts as a medium of exchange of heat from the substance to the refrigerant. In most cases, the evaporator is the coldest part of the fridge or freezer. In evaporator, the cold refrigerant moves at a slower pace in order to absorb as much heat as possible from the food. As it absorbs the heat, it gets hotter and turns into a gas called hot vapor. The refrigerant, which is hot and in gaseous form, is then enters into the compressor. There are two types of refrigeration systems: vapor compression refrigeration system, which is used in domestic and household refrigerators, and the vapor absorption refrigeration system, which is used in industrial refrigerators. The vapor compression refrigeration cycle is nearly 200 years old, but still it is in use. This method is used both in domestic and commercial refrigerators and air conditioners. In this system, the refrigeration cycle starts and ends with the compressor. The refrigerant in gaseous form flows into the compressor where it is compressed and pressurized. At this point, the refrigerant is a hot gas. The refrigerant is then pushed into the condenser, which turns the vapor into liquid and absorbs some of the heat. The refrigerant then proceeds to the expansion valve where it expands, losing the pressure and heat. The refrigerant coming out of the expansion valve is cold and slow due to the loss of pressure. It enters the evaporator in the liquid state where the exchange of heat takes place, thus cooling the food inside the refrigerator, and turns into gas, which is then pushed into the compressor where it can start the cycle again. It should be observed that the system operates on a closed cycle. The system requires inputs in the form of mechanical work, that is a compressor. It extracts heat from a cold space and rejects heat to the high temperature heat sink. Most of the modern refrigerators works on this cycle as it is the simplest one. There are only 4 fundamental operations required to complete one cycle. The power utilized in a vapor compression system is high-grade energy, that is electric power, for running the compressor motor. In vapor compression system, the vapor is compressed to increase the pressure by reducing the volume during the compression process, and due to this, a major part of the work is consumed in this process. If means were available for raising the pressure of the refrigerant without appreciably altering its volume, the work requirement will be enormously reduced. This can be done by dissolving hot gaseous refrigerant in some absorbent and supplying this hot liquid solution for compression purpose. The most commonly used fluids in the absorption system are water as absorbent and ammonia as refrigerant. Hot refrigerant vapor from the evaporator is allowed to mix with the absorbent in the absorber chamber called absorption process. This strong solution is compressed in pump instead of compressor without reducing the volume appreciably, as liquids are non-compressible. The heat of absorption process is rejected from the solution to the weak solution circulating in a heat exchanger, which is dipped in the solution shown in the figure. The refrigerant can be separated from the solution by heating the solution before it reaches the condenser. On heating, refrigerant evaporates and separates and then enters the condenser where it is cooled and converted into liquid form. Remaining weak solution is a mixture of large amount of water and small amount of refrigerant, goes back to the absorber chamber through heat exchanger tubes. Liquid refrigerant coming out from the condenser loses its pressure further in expansion valve and enters back into the evaporator coil to absorb heat, and the cycle repeats.